All right, so electrolysis of copper-2 chloride. This lab, we're going to look at a series of videos. One of the videos you've already seen. It's earlier in the playlist. It was when we did the conductivity of substances lab. So you can go back and look at that, or you can click on that video in this first part here. I'm not going to watch the videos with you. I'll just put them in the playlist so you can watch them, mainly because if I watch them with you, it doesn't really... For the ones that you need to hear the sound, you can't do that with me watching the video with you here, but I will talk a little bit about each of the videos. So in this first video, you can click on this to go to the video. This is one you watched with the conductivity of substances lab, so if you go back and look at that earlier in the playlist, you can watch it there as well. The one thing I will point out about this video is this is connected to one side of the battery, this is connected to the other, and it's flipped in the next video. So this side is the same as this side in this video. So you'll notice a little bit more what's going on. This is probably a better video to illustrate what's going on. So you can take a look and you can think about this. Things I want you to think about. What do you see happening to the wires? What do we know about copper and chlorine? Remember, copper chloride is an ionic substance. So what's it going to do when it dissolves in water? Think about that. Think about the substances involved in making copper chloride. So copper is a metal, chlorine is a nonmetal. So you'll have copper ions and chloride ions, and think about what charges those are. And use that to figure out what charge are these things in the water. Okay? And I'd encourage you thinking about what do opposite charges do, what do the same charges do. All right? So that's our main thing to think about there. After you've done that, come and watch this video. This video is a very just like quick 40-second explanation of what's happening in there. So you can watch this one and then take a look at that. After you watch that one, think about, analyze, were your ideas from what you saw above, what you guessed above, correct? What do you think? For copper to bond with other copper atoms, it must be a neutral atom. So when we're looking at the copper here that's forming, we see that it's bonding to itself. So what has to happen to that copper when it hits the wire in order to be neutral again? So think about what it gave to chlorine. Think about what charge it is and how it would become neutral again. All right? Question number 6, electricity is defined as the movement of charged particles. So for questions 6 and 7, I want you to think about, we talked about the movement of charged particles when we talked about electricity in the fall. So this is going back a ways, but we've talked about it a little bit since then. What is moving through wires that is the flow of electricity? What are the charged particles that are moving? So think about that. And then also, what are the charged particles moving in the water? The only hint I'm going to give you is that these are two different types of charged particles, and I want you to think about that. Number 8, what must be happening when a positive ion, a cation, touches a negative wire? And then what must be happening when a negative ion, an anion, touches a positive wire? So think about these questions, and when you're done getting your answers down, you're going to come look at this last video. And this last video is kind of going to help you check your answers. So have your sheet open to look at and think about and maybe change answers, right? Because this is going to be the oh, we're putting it all together video. So think about that. Think about, were your answers to 8 and 9 correct? What did you learn from the video? All right. That's all I've got to say. Good luck getting this done. And yeah, take care.